In this session, we're going to talk about zero-force members in trusses. What are they? Why do they come to exist? And how do we identify them? What is a zero-force member? When analysing trusses, we may come across members that carry no force. These are called zero-force members. Why are there zero-force members in trusses? Naturally, one might question the rationale for having such members in a structure. If a truss member does not carry any force, why have it in the first place? There are two main reasons for encountering zero-force members in trusses. 1. A zero-force member could act as a bracing for preventing a force-carrying compression member from buckling. That is, a zero-force member adds stability to the structure. 2. A force having a magnitude of 0 could develop in a member at some point in time when the structure is subjected to a time-variant load. Let's examine this scenario in more detail. Bridge structures are generally designed to withstand the load of moving vehicles where the load position changes as a vehicle moves across the bridge. Suppose we have a truss bridge consisting of 5 joints along its bottom chord. As a vehicle starts travelling on the bridge, the applied load position changes. At time t1, the load is distributed between joints 1 and 2. At time t2, the load is distributed between joints 2 and 3. At t3, the load is applied to joints 3 and 4, and so on. This moving load pattern continues until the vehicle leaves the bridge. The bridge truss must be analysed under each loading case. Note that a truss member that actually carries an axial force in one loading case may become a zero-force member in another loading case. For example, when the load is applied at joints 1 and 2, the vertical member attached to joint 4 carries no internal force. When the applied load moves to joints 3 and 4, the vertical member attached to joint 2 becomes a zero-force member. The ability to identify zero-force members in trusses is important for two reasons. 1. It speeds up the overall analysis of the truss. 2. It helps developing a better understanding of how internal forces are distributed in a structure. How do we identify zero-force members in a truss? There are 3 basic rules for identifying zero-force members without resorting to any calculations. If a truss joint is not subjected to any applied loads and is not supported by a pin or roller, then the following rules can be applied repeatedly to identify all the zero-force members. Rule 1. If the joint connects 2 members only, where the angle between the members is different than 180 degrees, both members are zero-force members. If this structure, joint F, connects 2 members only, there is no load or support at the joint, therefore both EF and CF are zero-force members. Rule 2. If the joint connects 2 members only, and the members are collinear, that is, the angle between them is 180 degrees, and one of the members carries no internal force, the other one is also a zero-force member. Consider the 2 members AB and BC. If the force in member AB is 0, since the members are collinear, BC is also a zero-force member. Rule 3. If a joint connects 3 members only and 2 of the members are collinear, then the third one is a zero-force member. Here, joint D connects 3 members. 2 of the members are collinear, therefore CD is a zero-force member. Let's look at a few examples. Here, Rule 1 applies to joint D. Therefore, CD and DE are zero-force members. Also, Rule 3 applies to joint H. Hence, BH is a zero-force member. If we consider P to be an axial force in a member vertically attached to joint E, then, according to Rule 3, EF is a zero force member. Similarly, if we assume Gx is the force in an axial member horizontally attached to joint G, then according to Rule 3, AG is a zero force member. To determine the force in each of the remaining members, the simplified truss can be analysed using the method of joints. In this example, Rule 3 applies to joints C, B, E and D in that sequence. Therefore, BC, BE, DE and DG are zero force members. See if you can identify the zero force members in these trusses.